Hi and welcome to biostatistics. Today we will talk about correlation, which is one of the most used statistical techniques. Correlation is actually the basis of many biological studies, from gene expression analysis to the analysis of clinical trials data. So let's dive in. You might notice that when ice cream sales increase, so do shark attacks. When ice cream sales decrease, the number of shark attacks also goes down. Does this mean that eating ice cream causes shark attacks? Of course not. In this case, sunny weather is making more people eat ice cream. Also, with good weather, more people swim in the sea, which in turn increases the chances of a shark attack. Ice cream sales and shark attacks are correlated, which does not mean ice cream sales cause shark attacks or the other way around. Causation means that one variable, often called the predictor variable or independent variable, causes the other, which is often called the outcome variable or dependent variable. Correlation, on the other hand, measures how two variables are related, so the association between two variables. When two variables are correlated, we cannot conclude that one variable causes a change in the other. This relationship could be coincidental, or a third factor may be causing both variables to change. So how can we know if variables are correlated? To visualize if two variables are correlated, we can plot them in a scatter plot. If there is a correlation, an overall pattern can be seen when the variables are plotted on a scatter plot. If this pattern can be approximated by a line, the correlation is linear. Otherwise, the correlation is non-linear. There are three ways to describe correlations between variables. A positive correlation means that as x increases, y tends to increase, and vice versa. If x decreases, y tends to decrease. An example of positive correlation would be height and weight. Taller people tend to be heavier. Negative correlation means that as x increases, y tends to decrease, and vice versa. For example, increased exercise is correlated with less heart disease. When there is no correlation between two variables, it means that as x increases, y tends to stay about the same, or there's just no clear pattern. For example, coffee consumption versus intelligence. The amount of coffee that we consume and our IQ level has a correlation of 0. In other words, knowing how much coffee someone drinks doesn't give us an idea of what their IQ level might be. Let's look at one last example. You might notice that places with higher numbers of sunburns have also higher numbers of cases of skin cancer. Does this mean that sunburns cause skin cancer? No, with this data we cannot say that sunburns cause skin cancer. But wait a minute, we can design an experiment to determine causation. For example, randomized controlled trials can provide good evidence of causal relationships. The goal is to isolate and manipulate the independent variable to observe its effect on the dependent variable and control the environment so that other external variables are eliminated. For example, we know that sunburns are caused by UV radiation from the sun. We will find that UV radiation damages DNA in our skin cells. Well, to be honest, here it just seems like the DNA is really clean and glowing, but just pretend it's DNA damage. Anyway, the point here is that DNA radiation causes DNA damage. If enough DNA damage builds over time and affects specific genes, it can cause cells to start growing out of control, and this is the start of skin cancer. So no, a sunburn itself does not cause skin cancer. It's positively correlated to skin cancer. However, overexposure to the dangerous ultraviolet radiation can damage our skin cells, weakening them and creating the opportunity for cancer to form. So please use sunscreen in the sun. So one last important question. How do we measure correlation? The correlation coefficient R shows both the strength and direction of correlation. It takes values from -1 to +1. A positive OR means, as you can probably guess, a positive correlation between two variables. That is, two variables move in the same direction. The higher OR is, the stronger the correlation is. When OR equals 1, that is a perfect positive correlation, meaning that if one variable increases or decreases by 10%, the other will increase or decrease also by 10%. If OR is 0, there is no correlation, so no association between the two variables. Remember, the scatter plot can either show that y does not really change even if x changes, or that there's just no clear pattern. As OR gets more and more negative, you guessed again, we are talking about negative correlation. An OR of -1 is a perfect negative correlation. It means if one variable moves by 10%, the other variable will also move by 10% in the opposite direction. And that is all for today. Squid-tastic! I hope this video gave you a clear explanation of what is correlation, how to visualize it and measure it. If you liked this video, please let me know, and also let me know what other topics you would like to cover. Have a great day and see you in the next one!